Not really. I'll do bagels.
If your ringer is on your cell phone right now, turn it off. Okay. Yeah, especially you guys. All right, so our next session, examining interaction-based testing. Matt Heusser is a dev tester trainer extraordinaire, co-founder of the Great Lakes Software Excellence Conference, frequent conference speaker, and author of the popular blog Creative Chaos. Sean McMillan writes code for a living. He supports his local ProMongers and XP users groups and thinks you should too. The most important thing in his life, however, is his family. He's full of excitement about being a dad. Please help me in welcoming Matt and Sean.
Thanks, Alan, for the fine introduction. Before we get started, a couple of people I'd like to thank that don't usually get mentioned in these kind of things. First of all, the people that did our peer review. I was impressed and amazed at this community. Before we even came out here, we got to fire our presentation by a number of people, very smart people, didn't pay them a dime, they took their own time, and honestly, they probably could be up here doing this talk with us, and I want to mention them by name on videotape. That'd be Elizabeth Hendrickson, John Cole, Carlos Henry, and Scott Miller. Second of all, the Google folks for planning, organizing, directing, and coordinating this conference, and actually losing money at it. You got to give somebody credit for that. So could you get a round of applause for those folks? So we're here today to talk about interaction-based testing, which is a developer-facing test technique. And it starts with a paper that Martin Fowler wrote talking about the difference between a mockist practitioner and a traditional TDD developer. Right? A mockist will always use a mock for any object with interesting behavior. A traditional developer tries to avoid them. And so either or, these are the results you're going to get one way, these are the results you're going to get another. And it's a great paper. If you haven't read it, if you're a developer type, I'd highly recommend it. And it's a start of a discussion about when we should and should not use mocks. And our goal today is to take that discussion just a little bit farther and talk a little bit more about the pros and cons and some of the details, what we've seen. So to do that, we're going to start at the very beginning and go very fast. Some people here are traditional black box testers. So we're going to start with the terms we're using. We're going to talk with what we mean when we say interaction-based testing and some of the patterns we've seen, some things that work, some things that didn't work, some traps people fall into. I'm a big fan of Agile methodology. I believe in use what works. But any good idea can be implemented poorly. So we're going to talk about some of the things we see in the traps people fall into. Still might be a good idea, but you might want to avoid this. And then we'll end with what to do tomorrow.
So one of the difficulties that has arisen in talking about interaction-based testing is that people don't use the same terminology. So one author will say, oh, I'm using mocks to do this. And another author will come along and go, but your mocks don't have expectations, so they're really only stubs. And then the first guy will go, but I'm using JMock to create them, so they must be mocks. And then you have a stupid argument on a web board or something like that. So this guy, Gerard Mazzaros, wrote a book called X-Unit Test Patterns, apparently. I was going to say X-Unit Patterns. And he actually broke down all the different kinds of what he called test doubles into a bunch of different classes. So at last, we have a consistent and precise terminology for discussing those things. So I'm going to go over these in rapid fire. A dummy is an object that you pass into some sort of call just because you have to pass something. It's required, but you're not actually going to do anything with it. Could be null. A fake is any kind of object that just doesn't do a good enough job to be the real thing. You've taken some kind of shortcut in its implementation. Simon had the HTML unit piece for his WebDriver, and one of the #1 complaints he had about it was it doesn't do JavaScript. That'd be a perfect example of a fake. You can use it for testing, but it doesn't really go all the way. A stub is a fake that returns a specific set of canned data designed to interact with your test case. A spy is a stub that does all the stub things and also keeps track of what methods were called on it and how many times they were called and with what parameters. Then you can go back and verify those afterwards. A mock is a spy that takes a set of expectations ahead of time. So if you said, okay, you can expect that our database, we're going to replace our database with a mock, you can say, okay, we expect our database to be called 3 times. If it's a SPY, you have to go in afterwards and say, assert number of times database was called equals 3. With a mock, you say up front, we're going to call you 3 times, and then when you call it the 4th time, it throws an exception.
So to explain how this can impact our development, I'm going to start talking about traditional development and do some compare and contrast. So our example here is your typical simple application. It's going to have some kind of user interface, some kind of model, and interact with some kind of hard boundary system we trust. Doesn't really matter what that is. I'm going to say it's a file system. This could be a database. It could be a web service. It doesn't really matter. So if I'm doing traditional development, I might start with some kind of I/O object that interacts with the file system. So we're saying, say we're writing some kind, a notepad replacement, trivial example. So to test my I/O object, I save some data, and then maybe I use your C APIs to go look at the file system and see if that file was saved. Right. After we write our I/O object, we write our document. We can't really do a lot with the document against the file system until I/O is done. So we did I/O first, and we write the document, call some of the same methods, and we test down to the file system, make sure it physically creates the file, physically appends to the file, deletes the file, those kind of things. Finally, we're going to write our app. And it's the same thing. We're going to test all the way down the wire. Make sure we actually create this file. You'll notice we're testing down every time, but we're developing up. It's a composition strategy. So if you're an agilist, right, we might say, well, we're going to develop everything in thin slices. We're going to add one feature at a time, but we're still going to develop those thin slices up. Okay. Next slide. With mocks, we can do things very differently. For example, we can start with the app. We can write the app first. How do we test that? Oh, we can define an interface, and anything can implement that interface. Our doc will implement that interface, and that's how they'll talk together. But for testing, stick a mock in the middle instead. Then save, open, append, all these different file operations. We can say, what message did the app pass down to the doc? It sent the right message down. We're going to trust the doc is going to work correctly. That's good enough for now. We finish with that. We can write the doc, define an interface, mock out our I/O layer. Same thing. We finish that. We write the real I/O layer. So the questions are, do the docs send the right stream of data to the I/O layer? Same kind of thing. We write the I/O object. We can even mock out the file system. And eventually we might test with the real file system. And of course we'll do a system test where we test the whole thing all the way down. But we're developing down. So we can start with the look and feel of the application. One of the big advantages of this, as I mentioned before, this file system is a hard boundary that we basically trust that's in place before we started. With mocking, and that might be a very slow hard boundary. If it's a web service, you might have to go halfway around the world to check your data. If it's a database, you might have a query that takes 20, 30 minutes to run, or a series of transactions. You might call a stored procedure. And you don't really care if the stored procedure executes correctly at this point in development. You just want to know, did the things that I'm working on send the right data across? Because we're separating responsibilities. I'm just responsible as an I/O object to send the right information across the wire. So if you mock out, let's say it's database. One of the problems we get in traditional development doing it this way is that all of a sudden our test suite takes hours to run. maybe 12 hours to run. And we can't get the fast feedback that we thought we were going to get with test-driven development because we got to run the test suite and do a bunch of work. And then if something breaks, you go, gosh, where was that thing? And is that thing still valid or not? And how do I retest that I think I fixed the thing? I guess I'll retest tomorrow. All right, that's no good. If we mock out our database, we can get our tests to run extremely quickly. I think Dave Crosby said something once like, some of my tests are really slow, they run in 5 minutes. All right. Yes. So I've compared and contrasted two different approaches. Next logical question is, when would you absolutely want to use mock objects? What are they good for? Especially to a black box tester, who cares, right? What are you guys recommending? Sometimes you have a requirement that you can't test with traditional methods. I'll give you an example. You got a payroll system. Payroll system is going to kick off at 9 o'clock at night. It's going to connect to the database and do a bunch of stuff. Usually with the things we work on, if we fail to connect to the database, we send an email to someone and say, I didn't connect. We log a message. If the payroll system fails, tomorrow morning nobody gets a paycheck. So that's not okay. So what we've got is a requirement like if your database connection fails, wait 30 seconds and then connect again. And do that up to 15 times in a row. And after 7.5 minutes or 15 minutes, then you send the page to a DBA or whatever you do. Well, if we're trying to do traditional testing on that, how are we going to test that? Are we going to bring our test database down for a large enterprise? Do we have the capability to do that? Do we just look at the code and say, well, it looks like it should work, so I'll trust it? If we mock out the database and say return false the first 14 times you are called, or return false the first 5 times you are called and expect to be called 6 times, we can test that requirement with some degree of certainty, some degree of trust, some degree of accuracy. So a lot of testing is, what do I believe about how the software works? And then, do I have the evidence to support that belief? We can use mock objects to create that evidence. So if that's the example of the pattern, what's the anti-pattern that goes with that? What if we accidentally mock out the software under test and just don't actually test anything? You say, how can that possibly happen, Matt? That sounds so impossible. That doesn't make any sense. I'll give you an example. It's 1983, minivans are new, Chrysler's making minivans. All of a sudden, these complaints start to come in of ununderstood acceleration. The cars are parked, sometimes the key's not in the ignition, and it shifts into gear, or it's in neutral, and it takes off across the soccer field. And it's always a soccer field, right? I have no idea why this is always a soccer field. Sometimes it's a picnic table. So 60 Minutes did an investigative story in the 80s on this problem. And when they did their little Andy Rooney, last 10-minute bite, whatever, they got a lot of calls and letters. Then they did a real investigation. And they hired an electrical engineer. And what he did was he installed a remote starter and a remote shifter. And he short-circuited the protection gauges in the Chrysler minivan and pressed a button, and boo, that thing took off right across the socket. So 60 Minutes wrote a letter to Chrysler Corporation and said, this is dangerous, this is bad, and you got to do something about this risk to public safety. And Chrysler wrote back and basically said, yeah, if you install a remote starter, you install a remote shifter, and you override the thing that sends the message to start the car is going to start. Wow. And that was the end of the investigative story, right? So something happened in that electrical engineer's mind, and those people, because they're real reporters, real journalists, doing real research, something happened in their mind. They kind of fell for a logic trick. And we've seen the same thing happen in software development.
Well, and so to take it a little closer to home, what I've seen happen is in GUI frameworks, GUI applications, you have some kind of event receiver method. And oftentimes that event receiver method has to have a certain signature. So you have an event receiver method that all it does is call a real do-it method on the object. And if you're working in a mockist mindset, remember that Fowler quote that was on the first slide that says you'll always replace anything with interesting behavior. you're going to find that you're copying your mock expectations for your do it method test into your event handler test, because you have to verify that it did something. You say to yourself, gosh, I don't want to verify that the do it method worked again. I already have a test for that. All I want to do is verify that the do it method was called. And you say to yourself, well, I could inherit from my real object and override the do it method with a method that does nothing other than call and assert that it was called true. That sounds pretty good to me. And so you do that, and now your tests are fast, and your test code is simple, and it's easy to read, but you never actually instantiate and check the event handler on your real object. So if you get the wiring for the event handler right in your derived mock and wrong in your real object, you're never going to know. It's because you're testing the mock.
That also doesn't cover exception handling. If your real object throws an exception, you never know about it because your mock passed. Another interesting thing we've seen is interaction alone, or interaction only. And the term interaction-based testing is really, really interesting. But let's pretend our software is actually a pull table. Right? And what we want to do is we want to test the pull stick. So what does a pull stick do? Well, it hits a pull queue according to a certain protocol. Go ahead. Okay. It hits a pull queue according to a certain protocol, and that queue will then hit the rack. Right? Interaction-based testing tests this. It tests the object in complete isolation and trusts that the rest of the world will work correctly. It doesn't test what happens when these balls hit each other and what goes in the pocket, which is fine as long as you're not trusting it as your one true way, your golden hammer. So, as I mentioned, interaction-based testing. The term is interesting. There's a very famous, is a National Institute of Standards and Technologies, NIST study. They did it on embedded medical devices and found that 98% of your defects can be found through the interaction between components. So it seems like interaction-based testing would solve that problem. It makes sense. A classic example for this is the Mars rover accident, where we had two systems that worked correctly according to their specifications, that communicated properly according to the correct protocols. Only one system was working in English units, it was yards, and the other one was in metric units, it was meters. And those are kind of close, but you can't use them for astrophysics. So when I say the software crashed, I'm not saying they had to reboot it, I'm saying it crashed into the planet of Mars, right? If we're testing units in isolation, that can actually engender this problem because we don't see them together. So the slide is, that's fine, but it's not sufficient.
So our counter recommendation to the problem of interaction-only testing is to have a balanced breakfast. And by balanced breakfast, what I mean is to balance your test strategy. And Pat talked this morning about unit tests, functional tests, and system tests. And interaction-based testing lives in the unit test world, but that's not all that you need. You need to have functional tests and system tests. And it needs to be balanced, right? You need to have the appropriate mix. So if you have 90% unit tests, 5% functional tests, and 5% system tests, maybe that's not where you should be expending your energy. Maybe you should spend a little more time and effort on your functional tests and a little less on your unit tests. Or whatever, maybe you've got the problem in the opposite direction. Well, so we've got the sugar smacks up here on the board, and little kids, they get told this is part of a balanced breakfast, but they don't usually go, Mom, Dad, I want some sugar smacks and toast and juice and a banana. They just want the sugar smacks. And this is sort of a analogy and a warning. The people in this room are really the thought leaders in the test automation industry, and we need to be careful about what we talk about. Because if we go out there and we go, interaction-based testing, woohoo, mocks, people who are listening to us are not going to hear as part of a balanced breakfast. in addition to your other test techniques. And they might get golden hammer syndrome, like Matt mentioned, and think, all I need to do is use mocks to test my objects, test the interactions, woohoo.
Which is really the isolations.
Right. So everybody in this room, take home to be careful what you, when you are a cheerleader, be careful to be balanced about it.
So another classic problem we've got, to illustrate, I got a story to illustrate this. But when we say I want to believe, we say we're going to trust that black box. So we've got a little slice of software under test. And when you compare the software we write to what's in Oracle or what's in Google, or not really that big. But that's the software we care about, and we're going to trust this big black box over here, the file system. We're going to trust Windows. We're going to trust Oracle. That's the basic approach. So we're going to put a mock on top. And that can be part of a complete breakfast. So some time ago, we worked with a developer to write a test suite for an application and it interacted with the database. And things went well. He had interaction-based tests. The tests all passed. We also did acceptance testing, other forms of testing. It went into production, no problem. 6 months later, the customer comes back with a request for added functionality, maintenance request. That's fine. And it gets sent for me to work on. So this is great, right? I've got a test suite I can fire up and look at and see the executable specification for the code, what the code should do. And I can start from there and I can add my features and make sure everything still works. I can press a button and get a green bar. This is wonderful. I'm happy. So what am I going to do? It's an update. What am I going to do for this update? Here's my idea. I go to the database, update a very specific row to 2. Then I press the button in the code to do the update for that specific row, and make it 1. And then I'll do a select statement and make sure that I get 1 back because I updated the row, right? Makes sense? It's a confirmatory test. It's very simple test-driven development. Not going to trust this to make sure the software works completely, but on the developer side, it's a good start. And I'm looking at the test suite and nothing ever connects to the database. Nothing. I call the developer over. I don't understand this. Where's the test like this? We didn't have time for tests like that. We did all mocks. Okay. We did really strong acceptance testing. And this is a developer tech. Oh, okay. So what I'm going to do here now is instead of actually calling the database, I'll just check the select statement that gets passed and the bind variables to make sure they're right. Right? That's fine. We're going to trust the database to do what it's going to do. Test it somewhere else. Test the update statement in the binder. No test like that either. So what do the tests do? The tests are confirming the number of times the database handler is called, and the number of parameters that are passed in. How did that happen? Turns out the classic example for interaction-based testing is a cache. So cache can work completely correctly and go to disk every single time and not be any faster than if you just went directly to disk. So what you do to test a cache, you mock out the file system and say how many times were you called. For a write-through cache, there should be 1 write and no reads, assuming the data's cached. That same strategy was taken and applied to a database application. And when you switch context like that, things get missed. We want to be careful about that.
So if you are doing interaction-based testing, how can you avoid having these sort of verifying worthless properties problem? Well, and I think the answer to this is to test larger pieces of your application at once. So one thing that you can do is you can build facades inside your application to cordon off subsystems. And then when you mock, you can mock out those facades and replace the entire subsystem. So you test your subsystems in isolation, not your individual classes or objects. Some people would say, but Sean, that's not unit testing. To which I say, okay, if it helps me to test the system and builds confidence in it, I don't care what you want to call
Yeah, this is sort of logic trap we fall into. Well, I'm using JUnit, and that's not a unit test. So really, I shouldn't do that, which is okay as long as we've got another system to do those tests in, if we're using Fit or some other framework. But if all you've got is JUnit, no one's going to arrest you if you do higher level testing. Actually, I want to mention Chris McMillan is a tester out of California who's here today. Can you raise your hand, Chris? And he's famous for a quote that I don't test for blocking conditions in my code. For example, if I've got a login, I might write negative tests. I might use a password that's incorrect or try SQL injection and make sure that you can't hack in. But I'm not going to write confirmatory tests for that, because every other function in the entire application, you need to be logged in first. So if any application any test passes, login works. I think that goes along with our test larger pieces suggestion. So I mentioned this earlier. It's interaction-only testing. One of the things I mentioned earlier, which is a great advantage, is that if you've got really long, slow-running tests, you can sort of cull those out and use mocks instead. And then your test suite can run really fast. You can get your test suite running in minutes, seconds, not hours, which is great. And for proving that an object does what you as a developer thinks it should do, that's great. But for proving the overall application works, now we've got a problem. Now we've got our Mars rover problem. So if you've got those old tests that we used to write, or if you want to write tests, oh, but it's slow. Gosh, I don't want to put that in the test suite that runs. I want to get fast feedback. What do? Our suggestion is keep it, run it overnight. Hook it up to continuous integration. Run it overnight. Then at least we're back to the daily build of the functionality. And it's a lot better than the daily build we had 10 years ago that was just a build. It's the actual functionality still works.
And so if you need some help getting that hooked up, it's not easy to set up, but the Mozilla project has a piece of software called tinderbox, which every time they do a check-in, it does a complete checkout on a half a dozen different platforms, builds it and runs a unit test suite, and then updates a web page. So if you break the build on Mac OS prior to 10, you might not know it, but Tinderbox will find out and tell you. And that sort of thing can help you with this sort of activity. The other thing that we want to recommend to avoid the empty test suite problem is sort of a way of changing how you think about using mocks. And one of the grand discussions in the literature about mocks is about how using mocks helps you with your design. Because if you're using mocks, you need to have a way to introduce them into the system. So you're more likely to pass things in as a parameter, which basically gives you dependency injection almost for free. Also, because of the way it causes you to structure your system, you're likely to get single responsibility principle. There are a whole raft of valuable software engineering bonuses that you get sort of as a side effect of using mocks. Having the mocking tools available during your development provides certain forces that cause you to code in a certain way. And this is a great thing, but it's not really a test technique. So what we're suggesting is that we call this isolation-based design. And I think that these techniques are still new enough that we can make that change, that we can stop calling it testing if its value is in design and start calling it design. And I know that test-driven development several years ago undertook a slight transformation to become test-driven design. I think that using mocks for design purposes, we can also call design, and people will understand.
A couple things I'd like to add to that. So I've had some pushback. Well, this is an established name. Interaction-based testing. It's popular and it's been accepted. Why would you want to change that? Right? It's not a great name. It's not a good name. I don't like the word requirements. I really don't like the word requirements. I've been on projects where the customers give us the big requirement list. Right? You go through the big requirements list and you say, gosh, there's one thing that to make the system self-aware and self-healing and all that. And we're not Google. And that's going to be really expensive. If we can strike this one requirement out, I can hit your deadline. In fact, I can be a month early. Can I strike this one requirement? And I've had engineering managers go to me and say, Matt, you're not getting it. They're requirements. They're required. They're not, you got to do it, right? And then you go to the customer and they say, yeah, sure, do it. Hit my date. Well, what just happened? The language we use influenced the way we thought about the problem in a way that didn't really help. So I don't like requirements. I suggest we call them desirements, right? That's probably never going to happen. I can go to this conference and this audience and talk about it, and we can laugh about it. And maybe that'll impact the way we do our work a little bit and the way we communicate with people, but that ship has sailed. That terminology is here to stay. I think we still have a chance with this. I also want to add specifically, we use a tool called Toad that'll generate metrics for your code. And last week, I went through and ran, and there's cyclomatic complexity metrics, there's a half dozen different complexity metrics, and maintenance metrics. And I ran 3 different pieces of code through that. I ran one that was just the horrendous legacy code that was awful. I ran one that we had developed about 1.5 years ago, under some time pressure, wasn't really happy with it, but wasn't terrible. And a system that we developed this spring using these interaction-based techniques, isolation-based techniques. The legacy code, I think for maintenance it said that if the score is over 1,000, you've got a problem, and if the score for complexity is, maintenance was under 90 and you've got a problem, and complexity was over 1,000, you've got a problem. And it scored for maintenance something like 7, and for complexity it was 21,000. Ridiculous. And there's like 8 different kinds of metrics for each of those, and that's probably about what they average to. For the older system, it was right on the border. There was a couple of things, 1,005, 1,100, or 87. The isolation-based code, which is a package, it looks at every individual component as a component. So what you'll get with this is you'll get more code, but it'll be broken up better with logically identified dependencies when you design it. Everything was a green bar. Everything was perfect. Nothing even close to the yellow. You might want to look at this sort of things. So the design was solid. Were my tests that much better? I don't know. But I'm very proud of the design work I did using this technique, and when I talk about it going forward, I'm going to call it isolation-based design.
So there is one thing you got to watch out for. If you're doing isolation-based design, you can run into a position where you compromise your design to fit around your tools. And I'll just give a true story example. We had an application that was developed using isolation-based design, and one of the requirements was that, this was a database stored procedure. One of the requirements was that it should run for the current system date. And the problem was that that was very hard to test because the data that would be pulled would be different based on the system date. So they said, I know, we'll use mocks. So they wrote a get sysdate function, and then they had some mocking tools that would replace a stored procedure in the database. And they would replace that with a mocked out get sysdate function that returned a single fixed value, run their test, and they could confirm that everything they expected came out. And that sounds great, until you realize that the actual software under test, the first thing it did was call get sysdate and assign that to a variable, which it then used throughout the rest of the code, which means that they could have made it a parameter, avoided having to invoke the mocking framework, and added a feature to the code that it could be run for a specified date. But they were so blinded by the convenience of their mocking tools that they made what I consider to be the wrong design decision. So if you're going to be mocking, be careful. Don't compromise your design based on what's convenient for your tools.
And I think that's nothing more than golden hammer syndrome, right?
Absolutely.
So what are we really saying here? What am I recommending that you should go home with tomorrow? I'd like to end with an illustration. So years ago, I was a cadet in the Civil Air Patrol. We learned about the 4 forces of flight: lift, thrust, drag, and weight, or gravity. And when you're 13, you think that thrust is always good and lift is always good, right? That's SR-71. But it turns out that you go through the aerospace book and you learn about these things, and it's actually a very delicate balancing act with the aircraft. When you're trying to maintain steady level flight, you actually balance all four of these factors because you have inertia, so you're already going 300 miles an hour this way. So what you want to do is not go up and not come down and not lose speed and not go faster, because you're trying to predict when you're going to get to where you're going to go by how fast your average speed is, so you want to maintain that speed. So when you're maintaining straight and level flight, those four factors have to be in balance. On takeoff and landing, they're very different, and they might not be what you would expect. Not only that, you have rules for how to behave in each of those places. They vary depending on what kind of airfield you're at. If you're a fighter pilot, or you're an experimental airplane pilot, private pilot, the rules you apply in each situation are going to be different because your context is going to be different. So if you take an experimental aircraft pilot pushing limits and you make him a captain in Northwest, you can be really careful about how you train that guy. Right? So the context matters. So the question, I don't think, is should we always mock, should we never mock? That's a good start of a discussion, and I think that I love Martin Fowler's paper. That's great. And he does have a few pros and cons in there. And the question should be, how much should we use, when should we use it, when should we not use it? So our hard and fast advice here is, yes, use mocks to verify requirements that you can't verify any other way. Absolutely. Use them as part of a balanced breakfast. For everything we do, we should be examining, do I need more of this technique or less of this technique? Do I need more acceptance tests? Am I spending too much time on testing in general? What's the balance between the QA group and the dev group? Do we even have a balance? Do we just all have all developers? Is that okay? How do we regulate that kind of thing? And we constantly improve. So I suspect that the way you use mocks, if you're working as a software engineer at Boeing, for example, is going to be very different than if you're working for a Web 2.0 startup. And if those guys switched, the Web 2.0 people would think of the Boeing guy as damaged to be routed around. He would be complaining about irresponsible software engineering all day long. And the Web 2.0 guy, he might, well, he could kill somebody. So our final advice is to examine these carefully for your situation and do what's right for you. If you do something, if I come to you afterward and you say I want to always use mocks because, and you've got a good reason, great, solid. You don't, somewhere in the middle, great, absolutely. If you're doing it because Matt Heusser told you to, or Sean McMillan told you to, or Martin Fowler told you to, you didn't get that from us. What are your questions?
I'm going to steal your mic, so I can steal it. So you'll have to get it.
Thanks. Steve Freeman. I was one of the authors on the original paper. And we spend a lot of time fighting off straw man arguments, and it's nice to see the balanced breakfast argument coming back again. I guess my only comment is we pushed a lot hard. I mean, for us, like you say, it's a design technique. And I think perhaps in the introduction, one of the things we try to avoid is using mocks to go faster. In fact, Joe Walls, who works for Google in London, has this line about only mock types you own. And that we've been damaged a lot in perception by this whole thing about it's about making the database go faster. And you have lots of fine examples. So I just wanted to sort of comment really just to emphasize that point. And it's about pulling relationships out of the code, if you like.
Thank you. I appreciate you bringing that to light. We've seen people use them both ways. I think what you're suggesting is absolutely the right way.
Other side, please.
I was actually just going to kind of mention a paper that people might find very useful. I think Steve actually wrote. Mock roles, not objects. It doesn't talk as much about when you should use mocks, but in terms of implementing it as a design principle. It's got a lot of helpful advice that walks you through that cache scenario, I think. and to turn that into a question. Can you recommend any more resources on how we might do that?
Well, so the three most influential mock papers are endo testing with mock objects, mock roles not objects that you mentioned, and Martin Fowler's mocks aren't stubs, which he revised this year, if you read it before. There's also a number of decent discussions of mock success and mock failure if you Google people's various blogs. I don't have any other specific papers to recommend that are written as papers, but there's a lot of good stuff out there.
There's a, if I can add, I believe Addison Wesley is going to be publishing a book called something like Software Professionalism in early 2008. Scott Bain's the author on that one from Net Objectives, and it does cover mocks as a design technique in some detail. It's again, you want to try to achieve a balance. That's the thing he's talking about, and that's his thing. But that's another resource.
Did you also mention mockobjects.com? We have material on that.
Oh, apparently mockobjects.com will be a useful resource as well. Thank you.
If you're taking notes, Rhino mocks are for .NET, JMock works for Java, Easy mocks also works for Java.
Right.
There's a half dozen frameworks.
Had a quick question. A lot of what you have discussed here sounds like it fits very well into a loosely coupled architecture where you're defining interfaces. What were your thoughts on that?
If you have the option to define interfaces, it's probably a good idea. Obviously, check your context.
Yeah, it depends. I was going to say it depends on your context. Thanks. But let's say you're writing a simple application. It's going to be 500, 1,000, 2,000 lines of code. You're probably going to get more code and less benefit out of this technique. If you're working in a large distributed object-oriented system where you have a problem keeping track of what's going where when, then I would absolutely recommend you look into mock objects.
Yeah, we had a web-based system. It wasn't a very big deal, but we hired some contractors to write it who wrote it using mock objects, and they came back with a big stack of printed out code, but there was a problem with that system. I don't remember what the functional problem was, but they had another guy write it as well, and he wrote it just in a straightforward manner and came back with that much code. And the question is, given that there is some overhead to building a mock-based test suite, is that overhead worth what you're going to get out of it?
So given the pretty common paradigm of splitting up tests into system integration and unit tests, it kind of seems like what you're advocating is muddying the waters between mocked out unit tests and integration tests that don't use mocks at all. I mean, most time when you write a system test or an integration test, you would never use a mock. So I'm not quite sure. Doesn't that sort of ruin the difference there?
Well, there's a...
I'm sorry, Carlin. I didn't quite understand the question. Could you say that again?
Yes. Are you crossing the difference between integration tests and unit tests? Are you advocating that those two just be merged?
Well, so I personally don't see a huge value in making that distinction. So I certainly don't have a problem with that. If there is value in making that distinction, by all means maintain it. But I think that, so a lot of times you use unit test as part of a design technique. And if you're separating out your design technique tests from your verifying that the system actually works tests, that's fine. The danger that we've seen is that some people go, oh, I'm using JUnit, so I can only write unit tests, therefore they should be completely isolated. And then they say, I don't have a tool for higher level tests, so I'll poke it with the mouse a couple of times. And that is what we are arguing against.
It seems like in a context with proper separation like that, you wouldn't have to worry about that problem.
If you've got good separation and good tools at all levels, then it's not a problem that you have. A lot of people have weak tools at one level or another, and they end up either using the tools that they have and ignoring the things that they don't have tools for, or using the tools that they have in places that they weren't originally designed for.
Yeah, or it all depends on context, right? If your application just isn't that big, do you really want to have a tool for our unit tests and a tool for our system tests and a different tool for our integration tests and a tool for our acceptance tests and a tool for, and then you have to maintain 5 or 6 different tools. That could be very valuable if you're working in certain contexts, not always.
So we do a lot of file glue extracts. We pull data out of one big black box system and put it in a file that can be imported into another big black box system. And there's almost no value in separating that code from the database. But it all depends on your context.
You mentioned in passing using facades to isolate subsystems, and I wondered if you could elaborate a bit more on how you go about using these facades or inventing them or that sort of thing.
Well, so this all came out of the discussion of testing things in complete isolation, and people would say, you have one class that you're testing, and you don't test any other class. Every other class that it touches should be replaced with a mock. And the example that I thought of was, well, what if you're implementing a tree, right? So you've got a tree class, and then inside that you've got node classes. Well, it doesn't make any sense to build a tree and then replace the nodes with mocks. You just can't test that. So you have to test the whole thing as a clump. And for someone who's a mock purist, like that Fowler quote on the first slide or second slide, I don't think there's an answer to that. And I think that that same pattern where you say, okay, these things form a logical cluster, right? You can take that to other parts of your application. So maybe you can test your entire GUI as a single cluster. How you would facade that, I'm not sure off the top of my head, but you could facade. So if you've ever done scripting of Microsoft Office applications as components, you can get an object that is Excel, right? And then you can drive that object through script. If you have a facade like that for the state of your application, you could replace the state of your application and test just your GUI, cutting them in half along that line.
Yeah. On the other side of that, right, you could have, say you have a web application that calls a web service. The simple facade for that is a teeny little VB thing that you press a button and it calls the web service and it tells you what happened, right? That's a facade. And you're testing that web service in complete isolation, separate and distinct from whatever it is you have that calls the web service.
If people have had some success with this, we'd love to hear more about it. If they try it out, we'd love to hear more about it. Tell us more about it, please.
So in the community, there's been a lot of push for doing more unit testing and doing a triangle approach where you do a lot of testing at the bottom, and then as you go up, less testing is needed. So you're advocating the opposite of that kind of? If you have limited resources, should you focus more on the bigger subsystems or type of thing?
So one of the things that we've seen come out of traditional TDD pre-mocks was that when you messed up one object, dozens of tests would fail because they used that object somewhere deep underneath. And I think that there's actually some value to that, because if one failure causes your test output to light up like a Christmas tree, you can catch the fail. That actually catches those interactions, the pool ball interactions that Matt discussed on the whiteboard. So if you have those kind of cascading tests, then you might not need as many of them. So I think it could still fit inside that triangle, but I think if you are testing everything in complete isolation, you can run into a problem where you tested this piece in isolation and this piece in isolation and this piece in isolation, but when this piece interacts with one of these other pieces, there's a failure.
Right. And it all depends on your context. I think that triangle is pretty solid advice to start with. So then you do it, and then you say, how's this working for me? What's my return on investment I'm getting from this technique? Should I try this other thing over here? We saw the quote from Deming this morning. He invented the plan, do, check, act cycle, right? Sure, we read the literature. This is a recommended thing. We try it. Did it work for us? Could we try something different? So we're constantly evolving our process as we go to fit what fits our organization and our organizational needs. I've told you about mine. I don't know about yours.
Something I would just add to the previous question was the Humble Dialogue paper about GUI testing. I thought that was useful. Anybody else questions?
Thank you.
Anybody else with questions?
Okay, thanks, guys.
Thank you all.